Firstly, I welcome all the participants via our college, Dr. Bapuji Savanti Institute of Engineering and Technology. Welcome all of you. So today's second day of faculty development program for hybrid electric vehicle, and our today's session leader is Dr. N.M. Jamadar sir, HOD at Yashoda Technical Campus, Satara. He has published numerous papers in international journals focusing on electric vehicle and power system. Also, he completed his PhD in electrical engineering, especially electric vehicles. Warm welcome, sir.
Yes, thank you, madam.
Hello.
Am I audible, madam?
Yes, yes, sir.
Okay,
So I
thank you, madam.
request
Please
you, sir,
continue.
please start your session.
Okay, madam. Let me share my screen first. Can anybody can confirm that whether screen is visible?
Yes, sir.
Yes,
And
sir.
is it in
Please.
presentation mode?
Yes, sir.
Okay, okay. Thank you. Okay, good afternoon, everyone. I'm Dr. N.M. Jamadar. I think the introduction has been given by madam. As my area of specialization in electric vehicle, so I'm supposed to hear and I'm supposed to deliver a session. First of all, I would like to thank management of the institute and of course Principal Dr. Sapate sir, who have given me invitation to deliver a session in front of you, all of you. So let's start a session by having a quick introduction to hybrid electric vehicle. So we have to ask one question, that what is exactly a hybrid electric vehicle? When we say hybrid, it's basically a vehicle or it's basically an automobile which consists of more than two mechanical energy sources. See, basically any kind of automobile required a mechanical energy source. Either we can get it from IC engines, internal combustion engine, or we can get it through the electric motor. Earlier in 90s era, where the conventional engine development starts, there is no much scope found by the electric vehicle. But in 1977 and 1976, the 2 years, we found that there is a crude oil crisis where happened, and that's why researcher started how to save the crude oil, so that in near future, if such situation occurs, so there will not be any shortage of fossil fuel. So that's why researchers started to search for electric vehicle and then hybrid electric vehicle. The motto behind hybrid vehicle is to save the petrol or diesel from the vehicle, so that its efficiency can be increased, and the fuel required for per liter fuel required for the vehicle can be saved. So this is basically hybrid vehicle which having two energy sources of mechanical energy. Here in the diagram you can see that energy source 1 and energy converter 1, similarly energy source 2, energy converter 2. Here there is some arrows has been mentioned, like black arrow, solid arrow, red arrow and blue arrow. The black arrow represents the traction power flow, that is, it's a pure flow of mechanical energy. The red arrow indicates that it's a charging power flow. When there is a need to recharge the battery, then power can be withdrawn from the either by external source or through the vehicle itself, and that can be charged. And the blue arrow represents the energy recuperation power flow, that is simply a regenerative braking. So this is basic skeleton of hybrid electric vehicle. We can easily identify that energy source 1 and energy converter 1 belongs to an IC engine, because energy source 1 will act as a petrol tank or diesel tank, and the energy converter is nothing but, if you are using petrol engine, then it will be a spark ignited engine, and if you are using diesel, then it's a compression ignited engine, SI engines and CI engines basically. And then here is one box, summation box is there, plus sign is there. It's basically a mechanical coupler or transmission coupler. Another energy source 2 and energy converter 2 is there, which represents the battery and the motor, and again it is given to the mechanical coupler. Thing is, here charging power flow is mentioned as energy source 1 to energy converter 1, energy converter 1, 2, again red arrow is there, energy converter 2, and then it will store in the battery. One more blue line is there, energy recuperation power flow, that is from load to the energy converter 1. As we can see that there is no provision from mechanical engine to regenerate the energy. There is only possible to regenerate the energy through the electric motor. So that's why this arrow is mentioned like that. Okay. So here we can easily identify that energy source to an energy converter 2 will act as a electric mechanism or electric motor drive, and the energy source 1 and energy converter 1 will act as a mechanical or the basically IC engine power flow. Okay. So this is about the quick review of the hybrid electric vehicle. Then we'll move to the basic types of hybrid vehicle. Without knowing the types, we cannot justify the how energy is going to be managed. So basically, in parallel hybrid electric vehicle, the power converter 2, that is battery e motor, that is electric motor, and the fuel tank and IC engine is connected directly with the transmission. Where you can see that right side series vehicle in which the electric motor is directly connected with the transmission. Nowhere you can identify the ICE, that is internal combustion engine, is connected directly to the transmission. That is the major difference between series hybrid vehicle and parallel hybrid vehicle. The third category came that plug-in hybrid vehicle. You can choose any series or parallel if there is a provision to recharge the battery externally. That is it means through the external charger. Then it is called as a plug-in hybrid electric vehicle. Just simply if we have plug to connect outside socket, then we can simply call it as a plug-in hybrid electric vehicle. In plain series or parallel hybrid electric vehicle, there is no provision to recharge the battery through external socket. There is energy management system who is looking after that particular how the battery is going to get recharged. The entire charging process is with the engine or engine generator set or with the load set. But in case of plug-in, we can have scope that we can just simply connect a charger to an external socket. That is the major difference between plug-in hybrid electric vehicles and normal hybrid electric vehicles. So these are basic three types. So we'll talk about what is energy management system. What is exactly an energy management? Basically, as we talk about the that structural differences that series and parallel, here that series hybrid vehicle will have no connection of IC engine with the transmission, but wherein that particular parallel hybrid electrical we will have direct connection of engine plus motor with the transmission. One thing I want to clear here that in case of parallel hybrid vehicle, the power sharing is in between electric motor and IC engine directly. That means the mechanical power, that is speed and torque, directly shared with the transmission. Where in case of a series hybrid electric vehicle, directly electric motor is capable to drive the vehicle, entire vehicle. So IC engine will not have any kind of direct mechanical coupling with the transmission. Instead, that internal combustion engine is connected with the alternator. Alternator will give some electric output, and that electric output is given to the electric machine. So here we can say that here in case of series hybrid electric vehicle, we can have a electric power sharing between engine generator set or engine alternator set and particularly battery, where in case of parallel hybrid vehicle we have to share mechanical powers directly. So this is the major difference between series and parallel hybrid electric vehicle, and we can easily understand that which kind of energy management system is supposed to be designed, because for parallel there is a mechanical power sharing, for series there is electric power sharing. So in no case we cannot have a same type of a particular energy management system for both series as well as parallel hybrid electric vehicles. So we have to design different energy management system, because in one case mechanical power is going to share and in other case the electric power is going to share. That's why there is a major difference between power sharing. So there will be a logical difference in energy management system. So, what is exactly an energy management system? The role of energy management system is to optimize the energy flow between, in particular, HEV. As I said, in case of parallel hybrid vehicle, there is need to manage electric power as well as electric motor power as well as IC engine power mechanically, and in case of series, there is need to adjust the electric power in case of engine generator set and the battery. So basically the role of EMS to optimize the energy flow, how energy is delivered to the load, that is to the vehicle, and how during regenerative braking it is again recaptured to the battery. That is the main objective of energy management system, is to optimize the energy flow. What is important? How effective energy management system is very much important when we talk about the hybrid electric vehicle. Basically, an energy efficiency, it will work on energy efficiency. Sorry for interruption. So it will work upon the energy efficiency, extending the battery life, reducing the fuel consumption, and balancing the performance. So energy efficiency is basically a term that is output energy and in ratio of output energy to the input energy. See, if we have no control over the power flow in particular hybrid electric vehicle, we may face the increase in losses. So the efficiency of particular hybrid electric vehicle may get reduced. So that is the major concern with the energy efficiency. Basically, our major objective is to have a maximum workout in minimum energy. So the major important aspect of this particular energy management system is to increase the energy efficiency. Second is extending the battery life. See, basically battery life depending upon the number of cycles. Standard lithium ion battery will have 1,000 cycles, that is 1,000 times we can charge and discharge. So if we are charging that particular battery once in a day, that is one in per day we are having one charge and discharge cycle, simply within 3 and 3.5 years we can exhaust our battery. So the role of energy management system is to coordinate energy flow so that these particular charging cycles get reduced. If the charging cycle get reduced, automatically battery life get extended. Third aspect is reducing the fuel consumption. Of course, the fuel consumption of particular vehicle is very important concern when we talk about the Indian buyer or Indian vehicle purchaser. So he will of course look for the fuel economy, fuel efficiency. The energy or well-designed energy management system can reduce the fuel consumption effectively. As we first point we talk about the energy efficiency. Of course, if energy efficiency get increased, automatically the fuel efficiency or fuel consumption of particular vehicle get reduced. And third, last point is balancing the performance. See, engine have different characteristics and motor have different characteristics. If you operate engine and motor at its optimal point, so we will get the highest efficiency from both the sides, that is from engine and that from particularly electric motor. See, basic difference in mechanical efficiencies of these two devices, that is engine and motor, is basically electric motor we can get efficiency up to 80 to 85% also, but when it comes to the IC engine, the efficiency may fall to the 35 to 40%. That means in 1 liter petrol, actual 350 ml is required to travel, for example, 20 kilometer distance. But in case of electric machine, 800 watt of out of 1000 watt is sufficient to travel that particular distance. So we can say that this difference in efficiencies will require a balancing mechanism so that engine will also operate at optimal position and electric motor also can operate at optimal position. Best example, we used to say that when iron loss is equal to copper loss, we'll get the efficiency at maximum for in case of electric motor. Just we need to identify this particular point when we will get the maximum efficiency from electric motor, and the role of energy management system is to try keep the particular losses, that is iron losses equal to copper losses is equal to iron losses equations in a balanced format, so that we will get the maximum efficiency and it will optimize the performance or it simply balance the performance. The key functions of the energy management systems are battery management. The battery management consists of charging, discharging, monitoring, and the very important state of charge. That is, charging is basically when we either connect external socket, the battery gets charged, or through the engine generator set, we can also charge the battery. Second is discharging. Discharging is nothing but when we deliver power to the electric machine, the battery is in discharging mode. However, while driving the vehicle, certain amount of power is also fetched from electric machine as well as from the IC engine. So discharging need to be balanced. When the battery is going to switch on, when it is going to switch off, that need to be decided through the particular energy management system. Then monitoring, very important aspect of battery management monitoring, because nowadays we may hear that EV catches fire. Such kind of news are floating through the media. It is because of improper monitoring of battery cells or load of the particular battery cells. See what happens basically when sudden acceleration mechanism happens, the motor will try to take large amount of current from the battery, and in this process the battery gets heated up, and due to excessive heating, when it reach ambient temperature, it will sustain. But once that ambient temperature limit gets crossed, the battery catches the fire, and automatically that EV or even the hybrid electric vehicle will catch the fire. So monitoring SOC is very important. Monitoring and SOC state of charge is, see, we need to know how much amount of energy is there in our battery, a vehicle battery, so that we can decide or we can have a plan for a journey. If battery is getting drained, then according to the particular power management unit or energy management unit have to take decision when to operate the battery and when to switch on the engine. Second key function is to power split between ICE, internal combustion engine, and the electric motor. The power split. See, basically, as I said, in parallel, there is a IC engine and electric motor, both are capable to drive the particular vehicle. In that case, we have to divide the power exactly. How much power will be taken from the internal combustion engine and how much power will be delivered through the electric motor. Basically, if suppose the demand of that particular vehicle is 100 HP, so we have to, that already decision has been taken already key, what will be the power share of IC engine or electric motor. We may have 60-40 split up, we may have 50-50 split up, we may have 80 and 20 split up. So that manufacturer has to decide what amount of power will be taken from internal combustion engine and from the electric motor. And the role of energy management system is to balance the power split between IC and electric motor. The third function is regenerative braking. In short amount of time, because basically the driving and braking operation depending upon the road and traffic condition, highway it is different, in city it is different, in urban it is different, or in rural area it is different. So based upon the braking events, there are two braking events basically. One is emergency braking and one is normal braking. In normal braking, the speed and the braking time is not much crucial, because when there is one speed breaker, we just simply slow down the vehicle and we just, after overcoming that particular speed breaker, we again accelerate the vehicle. But if suddenly somebody came in front of your vehicle, then that event could be a emergency braking, or sometimes there is some pothole or something, some obstruction is there in vehicle. In this case, driver take a decision and suddenly hit the brake pedal. In that case, in short amount of time, a large amount of regenerative braking energy is generated, because in this particular case, the vehicle wheel or the vehicle transmission will deliver mechanical power to the electric machine. So now in this particular braking event, the motor which going to drive the vehicle is now acting as a generator. In case of regenerative or braking event, this particular motor is going to act as a generator, and this will produce energy in a very short time, and the energy management system has to take certain decision how within short amount of time the energy generated during regenerative braking has to be restored into the battery. The last key function is energy storage and recuperation strategies. Energy storage, there are almost majorly two types of energy sources can be used. Basically, as per my understanding, there are battery is the prime source of energy. Apart from that, the supercapacitors or ultra capacitor also found best source of electrical energy. Both are capable to charge and discharge. So again, if you are using multiple electric energy sources, then what would be the decision taken by EMS when to take power from supercapacitor or when to take power from battery? This kind of decision has to be taken by the energy management system in any electric vehicle or hybrid electric vehicle. What are the components of particularly energy management system? There should be a battery management system. See, energy management system is the main controller under which we may have sub-controllers like battery BMS or battery management system. The function of battery management system is to control battery charging and discharging. See, we cannot control the temperature directly. For controlling temperature, there are certain other mechanisms are there, which like radiators and coolants. Certain arrangements are there. But when it comes to the exact control of charge and discharge current of the battery, because based upon the charge discharge current, the temperature of battery mainly depends, and so that the sudden charge and sudden discharge need to be avoided, and that majorly will be looked after by the battery management system. The second component of energy management system is power control unit, or it is simply called as a PCU. Basically, PCU or power control unit, which manage the energy between the motor, battery, and engine. It's a coordinator kind of thing, which will look after the motor energy, which will look after the battery capacity, and which will look after the engine capacity. And according to the demand of driver, see, because basically a common driver don't know what is going in the vehicle. He will either he will press the accelerator or he will press the brakes. So based upon the speed and torque requirement of a vehicle, because only driver is the user interface or a real-time interface with the real world. So whenever driver presses the accelerator, this power control unit will activate and it will take decision what amount of power is to be taken from the motor and what amount of power has to be taken from the engine. So this is the main function of power control unit. The third component of EMS, energy management system, is supervisory control unit. It acts as a brain of the EMS. See, because under which there are two controllers are together working. One is battery management system and power control unit. The overall monitoring will be done by the supervisory control unit. It is a brain and it is making real-time decision for optimal energy usage, according to which it will give command to the battery management system and to the power control unit. Now we need to understand the power flow. This is basic skeleton of series hybrid vehicle. You may see that here some arrows have been mentioned. That solid arrow is the traction, and the dash or dotted arrow, or you can dash arrow, is a battery charging mechanism. You may see that this, as I said, that there is a two types, series and parallel. There should be a different energy management system for series and parallel. This is basically a series vehicle. Here, fuel tank is connected with the engine is connected with the generator is connected with the rectifier, because the pulsating nature of engine generator set will be get damped to the rectifier, and the rectifier will give electric output, basically DC to DC. Of course, engine generator set may be DC AC type or DC DC type. So engine will give mechanical energy to the generator, or it may be alternator. Based upon the nature of energy, here you can see that three lines are there. That means it's a alternator. RYB, three connections have been mentioned in this particular lines, and that has been given to the rectifier that will simply convert to the DC. This electric power is given to the motor controller, and the motor controller will give or deliver electric power to the traction motor based upon the requirement of driver, because driver is the real world interface with the vehicle. So traction motor will generate some mechanical energy, and that energy is given to the transmission. So here you can see that engine is directly not at all connected with the transmission. It simply drives the generator and it will deliver electric power to the motor. And another side of this particular vehicle is a battery charger. This is simply a plug-in hybrid vehicle where, as I said earlier or in first slide, that there if we simply connect an external charger, then it will act as a plug-in hybrid electric vehicle. So battery charger will charge the batteries, and through the batteries there is one bi-directional DC-DC converter, and this DC-DC converter will deliver power to the electric motor through the motor controller. One major aspect of this particular vehicle is the sizing of machines, that is engine generator set and the traction motor is different. Here, if for example, if 100 HP capacity is required to drive particular vehicle, then the rating of electric motor should be 100 HP, which is equivalent to the maximum power demand by the vehicle. And the engine generator set may be a small size, because in nowhere case the engine is going to drive the vehicle, so no need of 100 HP engine is required. We can simply have a 10 HP engine which is connected to the generator of similar capacity around 10 HP, and it will deliver power to the traction motor through rectifier and motor controller. Here power split is between engine generator set and battery set. So we need to understand here electric power split is there. So if suppose instantaneous demand of particular, see, mechanical HP is 100 HP, but we need to identify in case of kilowatt. So for example, instantaneous demand is 50 kilowatt. Instantaneous demand of particular vehicle is 50 kilowatt. And here engine generator set is 20 kilowatt and remaining energy is with the battery, for example 30. So this energy management system has to take decision how much amount of electricity has to be taken from the engine generator set and how much amount of electricity could be taken from the battery. As I said, maximum demand is 50 kilowatt and the engine generator set have a capacity of 20 kilowatt and 30 kilowatt is battery. In any case, if it is beyond 20, then we can take electric power from engine generator set, that is out of 50 demand we can get a 20 kilowatt directly from the engine, and the remaining 30 kilowatt will be taken from the battery. Likewise, the 50 kilowatt demand will get fulfilled. If suppose demand is 20 kilowatt, total demand is 20 kilowatt, either we can turn on engine or you can turn on the battery only. You can, because maximum demand is 20, engine generator set is 20 kilowatt and the battery is 30 kilowatt. So either we can take electric power from engine generator set or we can take electric power from the battery directly. This decision has to be taken by the energy management system. How much electricity to be drawn from the battery and how much electricity to be drawn from the engine generator set. Based upon the control situation, there are certain modes have been listed. Like first one is the pure electric mode, in which pure electric mode means the engine generator set will be turned off and the battery will get turned on, that switches will get turned on, and entire power given to particular traction motor through the battery. Second is a pure engine mode, in which case battery gets turned off and entire power will be delivered to the motor through the engine generator set. That is, in either case, one part of electrical source will get turned off and counter will turn on. Likewise, third one is hybrid mode. That is, in both in this particular case, both engine generator set and battery both will deliver power to the load, that is electric motor. As I give an example of 50 kilowatt, that 20 kilowatt from the engine generator set and 30 kilowatt from the battery. So simultaneously both the sources, engine generator set as well as the battery, will deliver power to the load. The fourth mode is engine traction and battery charging mode. See, if suppose demand is 10 kilowatt and engine capacity is 20 kilowatt, then what about remaining 10 kilowatt power? So in this particular case, the 10 kilowatt energy directly sent to the traction motor and the excess 10 kilowatt energy is given to the battery for the charging. Again, we have to look for the SOC. As I said earlier, that monitoring of SOC is very much important. If SOC is 100%, then how we can recharge the battery? That is the major thing in particular energy management system. In this case, the controller has to take decision as the battery is fully charged and no scope to recharge the battery. Then what is used to turn on the engine? So such kind of decision has to be taken. Fifth is regenerative braking mode. The dash arrow will, here you can see that the mechanical transmission will drive the traction motor, and traction motor will act as a generator, and that power will get restored to the battery. So this particular mode comes under the regenerative braking. Sixth is battery charging mode. Suppose the batteries are fully drained and the vehicle is at idle position. You went to some, for example, if as I came for office to 10 to 5 job or 9 to 5 job, my vehicle is idle at my parking place. So in that case, the engine will automatically turn on, engine generator set, and it will recharge the battery until the battery gets full, and again it will turn off automatically. And seventh is the hybrid battery charging mode. Hybrid means certain amount of electric power will come from the engine generator set and certain amount of power will come from the mechanical transmission and to the electric traction motor through when it comes to the regenerative braking, and both together will recharge the battery. This seventh mode basically, when we talk about the hilly regions, when down slope is there, when we are moving towards downhill, under such case, there is no mechanical power is required for vehicle, because already due to the gravitational force, vehicle is supposed to drive automatically. Under such case, the both engine generator set and the regenerative braking can recharge the battery. These seven modes are most of the time common in all the hybrid electric vehicles. Without these seven mode, minimum these seven mode, no vehicle or no hybrid vehicle can work. The energy management system has to look into operation of all these seven modes. So when to have pure electric mode, when to have pure engine mode, when to have hybrid mode, when to have engine traction as well as battery charging mode, or any seven, all the seven cases, we need to understand that energy management system has to understand and has to take a decision which mode has to be turned on and which mode has to be turned off. Okay, this is about the series hybrid vehicle. Second is parallel hybrid vehicle. It is somewhat different. As I said earlier, the engine and motor both are connected directly to the mechanical coupling. So in this particular case, engine and motor both are capable to drive the vehicle directly, or to both are capable to deliver mechanical energy, that is speed and torque, directly to the vehicle. Here we need to understand that here engine on-off control or motor on-off control kind of strategies needs to be implemented. Again, the mode of operation remains same. Anyhow, we have to drive the vehicle, but here the mode of split is mechanical split. Earlier mode of split is electric split. So here, basically here we have to control the power electronic switches, but in case of series hybrid vehicle. But in case of parallel hybrid vehicle, we have to control the mechanical coupling. Basically, mechanical coupling is done through the, either by gear or through by shaft or by we can say belt or through chain. Whatever, the n number of transmission coupling mechanisms are there, but standardly there is a use of mechanical gears are the standards for the mechanical coupling in case of automotive industry. So here, for example, again, I will talk with the same example of 100 HP demand of particular vehicle. But here, we need to understand that the engine and motor, we need to divide the mechanical HP of 100 HP in engine as well as in motor. Say, for example, you may have 50-50% split up. That means in the engine will be of 50 HP and the motor will be of 50 HP, or you may have 60-40 split up, you may have 80-20 split up or 20-80 split up, whatever. This criteria should be decided at the time of manufacturing of vehicle, and accordingly we need to design the battery, that particular energy management system. So again, for example, the instantaneous demand of vehicle is 40 HP instantaneously, and we know that engine is, for example, of 70 HP and motor is of 30 HP, and our demand is 40 HP. What we can do, either we have option to turn on engine directly 70 HP, or we have to turn on both. Some part will be taken from motor, that is 30 HP, and 10 HP will be drawn from the engine. So here also, based upon the maximum demand of the vehicle, we can have a pure engine mode, pure electric mode, hybrid mode, battery charging mode, battery regeneration mode, anything, any seven mode we can be implemented here. But the mode of power split is mechanical, and the entire energy management system will look after the power splitting approach for the parallel or in a series hybrid electric vehicle. Now we need to talk about what are the energy management strategies or available strategies. Here, first one is a rule-based strategy. Rule means the switching rule. Simple on-off strategies for internal combustion engine and motor. As I said, pure engine mode. If there is a pure engine mode, the motor must be turned off. If there is a pure motor mode, then engine must be turned off, or vice versa. Or in some cases, both engine and motor has to be turned on simultaneously. So the rule will be the one of the rule will be, or fuzzy rule will get defined, and this will execute the operation according to the demand of driver, whether you want more power or low power. Second one is the optimization based strategies. These are advanced algorithms are designed to minimize the fuel consumption and emission. Here the objective is different. In rule based strategy, the objective is to uh, split the power between IC engine and motor. But when we talk about the optimization, the major role is to reduce the fuel consumption and reduce the emission. Again, there are certain sub parts of this particular control strategies. Rule-based control strategies will have deterministic rule, and the second one is fuzzy rule. Deterministic rule means either yes or no kind of operation, or whether to turn on and off. But the fuzzy rule will have n number of answers. Okay, turn on, then whether turn on from engine, turn on from motor. How much amount of power has to be taken from engine? How much amount of power has to be taken from motor? Like that, multiple queries will be there with the fuzzy logics, and which is best in this particular case instead of deterministic rule. Basically, and we will have some flexibility to have different functions, either trapezoidal function, triangular function, any kind of function can be taken, and that can be implemented as a rule-based control strategy. The second strategy, as I said, optimization based, where the role or the goal is to optimize the fuel consumption and emission. There are again two strategies: global optimization control strategies, and other one is instantaneous optimization control strategies. Global means global decisions. Whether when we basically there are certain drive cycles have been involved in this. Drive cycle means there are certain researchers have worked for automobile industry, and they have finalized that if there is a road speed time curve, basically we know about the speed time curve, that is nothing but a drive cycle. China drive cycle, New York drive cycle. If suppose you are driving that particular in New York, then what will be the performance of vehicle? There will be a speed time curve on which vehicle will attain higher speed, lower speed, middle speed, all braking operation. All the operation are mentioned in that particular drive cycle. Instantaneous optimization control strategy is such a way that it will take decision on the instantaneous mode, that is at actual current operating phenomena it will take the decision, wherein global optimization strategy already prerequisite data has been provided. Based upon this data it has to optimize the control strategy. But instantaneous, because Indian road and traffic condition is different, China road and traffic condition is different. Again, in India there are n number of regions. When we talk about our Western Maharashtra region, there are ghats also, and there are flat terrains also. When we move to the Himalaya, there are very high climbing terrain is there. So where the optimization strategy may be different. So if road and traffic condition or terrain is changing, then there will be a instant based utilization of instantaneous optimization control strategies. As we know about, there are talk about certain autonomous vehicles, like already Tesla have launched their Tesla Model 3 as an autonomous vehicle, that where no need of driver, or even though driver is there, the vehicle can drive vehicle based upon the instantaneous events, because there are certain cameras and certain thermal imaging is mounted on the front area of that particular vehicle, and based upon the instantaneous situation or instantaneous traffic condition, the vehicle will have either acceleration operation or brake operation. Such kind of instantaneous events can be incorporated in this particular optimization based control strategy. So this is about quick review about particular energy management strategies. Either rule based you can implement, or you can go with the optimization based strategies. See, basically those who are doing, especially if some listener is going to have a PhD, because all are MTechs, I think, in this particular FDP. So if you are supposed to do PhD, then you can have such kind of topics, that where you can have different kinds of implementation of strategy. See, the mode of operation is going to remain same. That seven modes, as I mentioned, that going to remain same. How we are going to take the decision to switch in between this mode to optimize the energy is the key, or the key planner in this particular energy management system. And on this particular software programming you need to work more, so that you can have good research publication for this particular energy management system for hybrid electric vehicle. And that could be a research topic for your PhD, or if somebody is doing MTech also, then there is a scope to do some research on this particular topic. This is control architectures. There are basically two control architectures. These are very basic. The hierarchical control, that is level of control, high level strategy versus low level operation. and the distributed control. That means power management spread across the component, that is engine, motor, and battery. So hierarchy is somewhat level, that is higher level controller and lower level. For example, it just has to supervise the battery management system and energy management system. It's a hierarchy. And the distributed control, what it actually taking, or it actually executing the decision taken by the hierarchy. So the power management spread across the component. The amount of energy is taken from engine, the amount of energy is taken from the motor is under the control of distributed control. But the decision strategy is with the hierarchical control. Here simply you can see in the diagram, there is one driver. Driver will have either two operations, that acceleration, brake, or in steering also. Because turning right and left also have an impact on vehicle operation. Then after pressing accelerator, brake or clutch, it will have some calculation, that is requirement calculation. What kind of requirement? What is the torque requirement of vehicle? See, if there is one passenger only, then torque requirement will be less. But if the vehicle is fully occupied by five passengers along with their luggage, then there will be a different torque requirement. So based upon the load condition in the vehicle or the weight condition of the vehicle, the requirement has to be recalculated every time. Then driving mode recognition. Driving mode means nowadays there are certain modes that uh, highway mode or some economy mode, what we can say, the speed mode, certain modes will be there, and based upon the requirement of driver, what kind of setting he have done, because there is setting knob in vehicle, we can say set city mode, highway mode, economy mode, sports mode, what mode he have set. If suppose he has given sports mode, then of course the torque requirement will be higher. But when driver sets particular city mode where torque requirement is less, in this particular case, that requirement of torque will get changed. So it is again a driving style. Certain people will have a requires higher torque to drive vehicle, or certain people like to drive a vehicle at higher speed. So that drive mode recognition is also very much important. Here, when ECMS control based control is given, that is hierarchical control is given, it will have one more sub controller, that is fuzzy logic controller, where SOC is given, and the entire loop is closed with the driver, this particular controller, because from driver also it will take one signal that how much amount of acceleration is pressed and how much brake demand is there. This is given to the energy management system, and according to that, it will take power from motor and engine, and the engine motor power is delivered to the vehicle. So this is basic, very basic skeleton of energy management system, where we can identify that the input is basically state of charge of battery, and driver. Driver means that acceleration and brake command given by the driver, and the mode selected by the driver, and according to that we have to that particular controller has to take the decision and has to decide how much torque to be taken from the motor and how much torque to be taken from the internal combustion engine, and accordingly the decision has been taken, and the particular vehicle will be driven. Again, there are the EMS algorithms are there, heuristic techniques, again, rule-based energy distribution, model predictive is there. We have to set a model for energy levels, how much energy will be given in this particular mode, and likewise we have to decide, and fuzzy logic. It is always flexible to have a fuzzy logic control, because when we define certain set of control, then it is possible to have a switching mechanism in between engine and motor. Real world application who have implemented this particular energy management system. Basically, Toyota Prius was the, and Chevy Volt. These two vehicles have first vehicle manufacturers who have launched commercial vehicles. Earlier era there was the prototypes. Majority of the vehicles were was with the prototypes. But the Toyota Prius and the Chevy Volt have the first market leader in the field of hybrid electric vehicles, who have launched their vehicles in around 2005-6 era, and but however there is no much awareness in the buyers or the owners of the vehicle. So the Toyota Prius and Chevy Volt, we are, even in my particular age, Till now I have seen only one Toyota Prius on the road. But nowadays the Maruti Suzuki and Toyota are the leading manufacturers in India for the hybrid electric vehicles. The Toyota is also having certain vehicles like that particular Innova, and then there is one vehicle named with Urban Cruiser. Urban Cruiser is similar to that of Grand Vitara, which is owned manufactured by the Maruti Suzuki. These two manufacturers are now leader in manufacturing of hybrid electric vehicles. These are parallel hybrid electric vehicles. The majority of vehicles available in the market are of parallel electric vehicles, because in case of series you may seen that one component extra required, that is engine generator set. Engine is of course there in both series or parallel. Engine and motor are the mandatory components in both series and parallel. But in case of series, one additional device, that alternator is required. If we add additional component, it will add extra weight, extra cost to the vehicle. So majority of manufacturers in India or even in abroad, they are preferring the parallel hybrid electric vehicles. One vehicle I would like to mention, BMW i3. One model is there, BMW i3. It is a series type hybrid electric vehicle which have combination of both engine alternator set. So basically all the vehicles requires energy management system, and basically energy management system having its brain, that is a program. The optimization in program, that is nowadays there is a machine learning and other things are AI is coming into this programming techniques. So the in coming days, the vehicles are becoming more and more smarter. The AI is utilized in already in Tesla. Basically, it's a pure electric vehicle, even though, but the AI plays very good role in this particular vehicle, as there is no need of driver, as we can say. Nowadays, certain systems are going to be deployed in vehicle, that is ADAS, automatic ADAS, that is lane assistance system, that it will not allow vehicle to move out of the lane. So this automatic drive assistance system is there, ADAS system is there. That also a part of energy management system, because without knowing the lane or without knowing the traffic, how energy is going to be get balanced in particularly that engine and motor set. So again, there are different modes of driving, that is city, highway, and sports mode. These are three modes only I mentioned, because majority of vehicle will have these three modes only with a different name. Some vehicle may have some different name, and some vehicle may have the city, highway, and sports mode. Or some may have, instead of mode, some may mention ultra mode or ultra power mode. So that means the highest power is required by the vehicle. City and highway and sports, all the three modes will have a different need of speed and torque, because in city we require torque because speed is less, and in highway we require higher speed, torque is less. In sports mode, usually if we are going for the hilly region, we require sports mode where speed and torque is having crucial requirements. So this is the real world application of energy management system. What is the future of this particular energy management system? See, with the integration of AI and machine learning, these particular energy management systems are becoming more adaptive. They are becoming self-learning. They are taking decision based upon the previous incidences. So the AI and machine learning will be the game changer for the software industry who are going to manufacture these particular programs for energy management system. I know one company in Pune, KPIT. KPIT is basically IT company, software manufacturer company, but they are manufacturing or they are producing software for the need of electric and hybrid vehicles. So their major client is in the automotive industry, and if they are involving AI and machine learning techniques in their softwares or in their programs, of course, definitely there will be an increase in efficiency, there is increase in reliability, there is an optimization in energy flow could be possible. The second is smart grid integration. Sooner our Indian electric grid is becoming a smart. Smart means basically, as of now, somebody is coming to your house and he's clicking the picture of energy meter, and based upon the reading recorded in that particular picture, the energy bill is calculated and that is sent monthly. But in smart grid, right now in certain cities there is an installation of prepaid meters where without having pre-recharge you are unable to utilize the electricity, and the electricity consumption will be directly available on your mobile phone. Even you can see now also at 4 o'clock how much amount of electricity is consumed in my house. Even though you are at your office place, you can see from this place also. So this is the smart grid, and in smart grid there is a concept of V to G, vehicle to grid, and grid to vehicle, G to V, energy flow between vehicle to grid. Because as per the Niti Aayog, government of India, their claim is by 2030 almost 40% of vehicle in India will be the electric or hybrid electric vehicle in either form. So there is a huge power pool in terms of battery will be available by 2030, and basically see only 20 to 30% vehicles are running on the road, and remaining are parked in either in home or in anybody's offices. Every school campus, college campus, any industry you take, morning 9 o'clock, everybody will travel to that particular place and he will park or she will park their vehicle in their parking, and then they will do the job for up to 5 o'clock, and again they will restart their journey towards the home. So this particular standby vehicle will act as a power pool. So in such case, when there is need of excess power, the smart grid have capability to take this particular power from these particular vehicles which are under parking place or which are under not utilization, and when they are supposed to start. For example, if battery required 1 hour to get recharged, and he know that 5 o'clock that vehicle is supposed to start. So at 4 o'clock that vehicle will get recharged and the battery will get full until the 5 o'clock. And for example, if that person is entering to his house at 6 o'clock, and evening 6 to morning 8 o'clock, no movement will happen. Under such case, through the parking lot, the power will be taken as a backup through the battery, and that can be given to the grid. So grid to vehicle and vehicle to grid. Third point is energy harvesting, that is capturing ambient energy, that is solar regenerative energy. Because in coming days, solar electric vehicles will also come into picture. That roof of vehicle will get mounted with the solar panels, and certain amount of energy will be used through the sun or through the solar power to recharge the battery. And the regenerative braking, that I said that in short amount of time when the driver apply the brake, the electricity get regenerated through the motor, and that motor will act as a generator, and that energy gets stored into the battery. This is simply a energy harvesting. So again, the energy management system or the use of AI or machine learning techniques can enhance the energy harvesting capacity or capability of these particular vehicles. Thank you. This is from my side. If anybody have queries, question, then they can ask. Hello?
Hello.
Yes, sir.
Sir. Please, sir.
Sir, I have a small question.
Yeah, please, sir.
Uh, you mentioned about the parallel and series hybrid vehicles, sir.
Yes, yes, sir.
But I just want to know कि in parallel hybrid vehicle, you mentioned that engine and battery both are driving the vehicle. I mean,
Yes,
the
yes.
power is given to
Engine and motor.
this motor.
Yes.
Yeah. But in that case, how to manage the torque and speed of both the entities, like
There are
engine and
basically,
battery?
yes, 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 yes. So there are basically two types of coupling mechanisms are available: speed coupling and torque coupling. Okay. So in
Okay.
speed coupling, the speed of engine shaft and motor shaft get added. So for example, if engine RPM is 3000 RPM and motor RPM is 3000 RPM, then output will be a 6000 RPM. This is a simply gear mechanism where we can adjust the gear ratio 1:2, 2:1, and we can have an addition of speed. That is the one case. Another case is a torque coupling where the torque of engine and motor will get added. For example, 50 Newton meter torque is from engine and 20 Newton meter torque is from motor. Then the output torque will be
Right.
the 70 Newton meter. So these two coupling mechanisms are there, but however, these two both are required in hybrid electric vehicle because the vehicle will have speed requirement as well as torque requirement. So it is simply a speed torque coupling mechanism is there. So for that purpose, basically a gearbox is used or separate. It is called as a planetary gear system. So planetary gear system, there is one central sun gear is there and surrounding planet gears are there, and all three gears are mounted or closed loop with the ring gear, and two planet gears are connected with one is with the engine shaft and one is with the motor shaft, and the both gears are together driving the sun gear, and the output of sun gear is given to the axle.
Sir, and another question is,
Yes, sir.
nowadays these accidents are increasing in electric vehicles.
Yes, yes, yes.
So having said that there are different securities and all those things are available,
Yes.
still why there are accidents taking place? With
Basically, accident is on battery side. The major,
yeah,
the what we can say, team player in that accident is the battery side. It's a false monitoring of battery temperature and battery SOC. See, battery is already having 100% fully charged, and we are keep on giving the energy. What will happen to that battery? Simply, battery will not accept the energy, but due to the battery resistance, the temperature of battery goes on increasing, and this excessive temperature will cause a fire in the vehicle. So basically, battery temperature and battery charge discharge current monitoring is very important. And if this system gets failed, automatically temperature will reach beyond its limit, and EV will catch a fire.
can we incorporate some firefighting devices inside the vehicle, sir?
Yes, certain prototypes have been implemented, like sudden, there is some firefighting system like sudden flow of that foam or some powdered firefighting device is
CO2.
there. Yes, CO2, yes. So, and even one powder type is there, exactly. Gas, the CO2 is
Yeah,
gaseous type, and one more powder type is there, which will
yeah, yeah.
so such kind of possibilities there, but however, due to the space constraints in the vehicle, we need to see that
Right.
how in a small amount of space how we can install such kind of firefighting devices. Scope is there, sir.
Okay, sir.
Even
Okay, thank you, sir.
alternatively, as like we have a radiator system for engine, coolant and
Right.
radiator system. Such kind of systems also can be incorporated with the, especially when we talk about the managing temperature of battery.
Okay, that will keep the temperature cool, actually.
Yes, yes. If battery is cool, then there is no chance of getting fire.
Right, right. Okay. Yes, sir. Thank you.
Yes. Anybody?
No, sir, no any doubt.
Okay.
Basically, you just described the whole configuration series panel. That is too much syllabus, and you just define in a smoothly way. So thank you, sir, and thank you from our behalf our institute, and
Yes,
I
ma'am.
also thank all the participants.
Okay. Thank you, madam.
So I just declare today's session is concluded. Thank you, sir.
Okay. Thank you, madam.